should download the pizza tutorial. You can, it's on my blog at this page, but you can download it directly from this URL. And I'm just pointing out here that for future use, it's a good idea to check back here, because I've been updating it regularly, and I'll probably be updating it some more in the future, especially some of the later sections like on Shackle and Sparkle. So just some conventions for the tutorial. Most of the tasks, like for creating classes, properties, and things, are in sections labeled exercise, 1, 2, 3. And so for this lab, you should try and get through exercises 1 through 26. What we're doing here, another convention is that all the user interface actions, so things to click on, text to enter, menu options, that kind of thing, are going to be highlighted in gray. So if you're working on something and if you're in doubt about something, the first thing to look at is for things that are highlighted in gray, and those will be things that you need to do in the user interface. As I mentioned in my talk, all OWL constructs, so classes, individuals, properties, are called entities, and all entities in the tutorial are in Consolis font. There's a minor thing is that there in the, in fact, I think I'm going to go to my protege to show this. So in the protege user interface, there's one tab that's the entities tab. That's this tab, and it's
Michael. Yeah. Michael, I think you would like to share your screen.
Oh, yeah, that would help, wouldn't it?
I think that would be good, because
sorry. Sorry about that.
I have made you already the co-host, so you can share your screen.
Okay, so you can see the whole screen now?
Yes.
Okay, good. Sorry about that. Okay, so actually, let me go back to where I was. We're going to be using this document. You can, if you don't already have it, you can download it from this URL. As I said, everything is going to be, the main things you're going to be doing are in sections called exercise. We're going to try and get through exercise 1 through 26. User interface things are highlighted in gray. And what I was starting to show here, this is a very minor thing, but I just thought it might confuse some people. So there's, in the protege user interface, there's something called the entities tab here, which it has you see it?
Can I just interrupt?
Yeah.
Can you please share the URL in the chat box so we can access it?
Oh, sure, of course. Hang on.
Thank you.
There we go. Okay, it should be there. And so the point I was making about the there's an entities tab here that has like classes. It's got all these sub tabs that are like also major tabs. So you can access them like the classes tab underneath the entities tab, or you can go to the tabs and actually just get the classes tab as a standalone tab. or like, well, like this one, like the object properties, you can see it here, or you can see it here underneath the entities tab. So I think I was a little inconsistent in the tutorial in the way I described it. Sometimes it's described as going through, so sometimes it's described like going to the object properties through the entities tab, and sometimes I described it as just going directly to it. It's a really minor thing, but just, you know, I thought it might, just in case it might confuse people. Okay, so, sorry. So we're going to begin with chapter 4 on page 10. And exercise, the first exercise walks you through creating a pizza ontology, and then the further exercises you add classes, properties, and things like that, and continue through the rest of chapter 4. And like, if anything at all is unclear, you know, please ask questions either, and I'll have the chat up, you know, or just ask verbally. And please don't be afraid to ask questions. You know, that's otherwise things will be boring for us because we won't have much to do. Now here I'm just going to go through this real quick, but these are the main steps just to give you kind of a high level overview of the tutorial. So to begin with, you're going to do the setup. You're going to create a new ontology and set the preferences in file preferences new entities and file preferences renderer. And you're going to install the Propellet reasoner. Then the next thing you're going to do is define some primitive classes, some disjoint, and you're going to describe that some of them are disjoint, and you're going to use the classes tab for that. Then you're going to use from the main menu. So that's like from Protege from here, there's tools. Actually, I have to click on a class first. There's tools, and then you use create class hierarchy. That's what you use to, that's what you're going to use in the later steps where you create the pizza base and the pizza topping. Then you're going to create the property hierarchies for has ingredients and its sub-properties and its inverses, and define their domain and range. And you'll note that you don't have to define all that much. And by the way, that's why one of the things I encourage people to do is, like, after almost every change, run the reasoner, and it'll do work for you. Then the next step is you're going to create primitive subclasses of pizza, which is named pizza, and then margherita pizza, Americana pizza, and so on. You're going to create a class that is invalid, that it's equivalent to all nothing, just to see an example of the reasoner. And you're going to create some defined classes. So this is a classes with necessary and sufficient conditions, so that you can see that, actually, I don't think you'll have any instances at this point, but what you will see is that it'll change the class hierarchy once you define these defined classes. That will actually change, the reasoner will rearrange the class hierarchy. And then finally define the enumerated class, which is spiciness. And so I'm going to go through this real quick. These are what the setting preferences look like. This is what the new ontology, the active ontology tab looks like. Here's what it will look like when you're creating 3 basic primitive classes using the classes tab. Here's what it looks like using the tools create class hierarchy, first for pizza base, and then there's a much more involved one for pizza topping. And so the reason you do this indentation is that every level of indentation means a subclass. So this means like cheese topping, and then so mozzarella and Parmesan topping are going to be subclasses of cheese topping. And also you'll note that by using this tool, you just put the suffix topping here, and you don't have to include it in any of the things you type in. It'll be added automatically once you finish using the tool, using the wizard. Then finally, then the has ingredient property with the hierarchy and inverses. And so you'll notice here, and this is an example of what it looks like when the reasoner infers something. When the reasoner infers something, it's highlighted in yellow, and there's always a question mark next to it. And actually, I encourage you to once in a while click on those question marks, because that will show you how the reasoner can tell you how it justifies any particular inference. So then this is what it looks like creating the subclasses of named pizza. So these are all primitive classes. So all the axioms go down here, not in the equivalent to. Although when you create, when you create the defined classes, what you're going to do is first you're just going to create them as if they were primitive classes. Then you're going to use an option in the edit menu that where you click on a class and say convert to defined class, and it'll move the axiom from the subclass up to the equivalent to section. And I think I skipped over one part. So this is what it looks like, the explanation you're going to get when you create a class that's inconsistent, that's equivalent to all nothing. And this is the explanation you'll get as to why it's inconsistent. Okay, so that's it in a nutshell. I think now that people should just get started, and if you have questions, please ask us as you're going.
So, Michael, I think
Yeah.
it would be good now that we ask the participants, and we also show that adding couple of classes, maybe 2, 3, or maybe those 4 primitive classes that you showed earlier on your slide. So we can actually type by our own, so that they also go along with us and do things, so that they feel that okay, that's the way they can add the classes, and then also the same applicable for the properties. So maybe we can go by that, by doing ourselves, and then they see and they also do by their own.
Okay, you want me to do that?
Yeah, if you want, or you want me to do that, it's fine. So anything is fine.
Well, the one I have loaded is already.
Yeah. So what you can do possibly.
Why don't you go ahead?
Yeah.
Yeah, go ahead.
So what you can do possibly, you can just keep that open, that pen, that is, yeah, that's, you can make it, yeah, you can make it available for them to see. And let's just we instruct and see that whether they are able to add it by their own. And if there is any problem, then probably we can again show and type it and show it that how things can be done, right? So I request all the participants. So as Michael already said in the last session also, that OWL thing actually is the root node. So whatever the ontology that we are going to build, there will be always a starting node and there will be an end node. On Protege interface, you will see only the starting node, that is OWL thing. You don't see the OWL nothing unless we run the reasoner. So what you do, so this I would request everyone that you open your Protege installation and just go to that class tab, and then you just create a couple of concepts as it is shown on the screen. So maybe Michael, I think you can keep that Protege that interface only, and let them to see and type it, because they may not be able to remember all those classes. So maybe they can start with pizza. So you may expand that pizza, and under that the subclasses, so that they can see that tree and type by their own.
Well, so I mean, if they're so the first thing to do is to go to the well, I guess you don't really have to do this. The first thing to do is to go and set the preferences. So create a new ontology, and then go to file and go to preferences. Okay, and then go to new entities and make sure that it's active ontology IRI, and that it's configured. Oh, that it's user supplied name. That's the important thing, because I think the default is auto generated ID.
Yeah.
One to be user supplied name.
So it's the by default one, I think. So it's
and then also go to the renderer and make sure it's render by entity IRI short name. Okay, so user supplied name, file preferences, user supplied name, and then on new entities, and then render by entity IRI short name. Then now once you do that, you go to the classes. I'm going to get rid of this thing. You go to, if you don't have it already, go to Window, Tabs, Classes. Okay, and then go to OWL thing, and then you're going to so you're going to create pizza, pizza base, and pizza topping. So click on OWL thing, and then click on this little icon here, which is add subclass, and then that'll prompt you for the name of the class. So you do that 3 times, and you'll end up with pizza, pizza base, and pizza topping as subclasses of OWL thing.
Participants, if you have any doubt, you may unmute yourself and ask. Otherwise, you may try to do the same thing in parallel.
Sir, if I want to, sir, hello.
Yes, yes.
Yeah, go ahead.
Sir, if I want to delete any class, how to do that?
So see this little, here, let me click on this. So see this icon here, the circle with an X through it. You just click on the class you want to delete, and then click on that, and then that will delete the class.
Okay, okay, sir, thank you.
Okay, so in fact, here, I'll show just an example. So here I'm going to create a new subclass. I'll just call it new pizza. Okay, so that's how you create a class. Now, if I wanted to create a class that was at the same level as this, I use this icon. If I want to create a subclass, I go here. So to create pizza base, I could either click on OWL thing and then click on the subclass, or I could go to new pizza and I could click on that, and I'm going to call that new. Of course, you should just obviously not say new. I'm just putting new because this one I've got is already got all the classes in it. So and then the same thing for pizza topping. And if you want to delete a class, just click on it and then do that, and it'll ask you to confirm, and you say yes. Now, the next thing you're going to need to do after that is go to File. Well, actually, first go to Reasoner and see if you have the Pellet Reasoner. You may not. I'm not sure if it's one of the default ones.
Sir, I want to ask one thing. Can we
Yeah, go
edit
ahead.
the class?
I'm sorry?
can we edit the name of class or we can directly delete it? Is there any option to edit the name of class?
Yes.
Oh, yes. If you want to edit the name of the class, click on the class, go to refactor, and go to rename entity. And then it will give you a window, and you can change it to whatever you want to.
Sir, could you make the screen a little bigger, sir?
Sure.
Thank you.
So when you've got those three classes defined, the next thing is to check the reasoner and see if you have pellet. If you don't have pellet, then go to File, check for plugins.
Michael, so
Yeah.
Pellet by default that because all of them have installed the 5.5.0 and
Okay.
Pellet is the default reasoner in that. So it's
Oh, it is? Okay,
Yeah,
great.
yeah.
I wasn't sure. Great.
yeah, so
Awesome.
it's they have.
Good.
I
Good.
don't
Thank
have
you.
it on mine. I do have installed 5.5.0. I am not able to see the option.
What options, ma'am?
No, I mean, I am not able to see under reasoner. I'm not able to tell it, though I have installed 5.5.0.
Okay, so then maybe in your case, then Michael, you may then show that
So
yeah, plugins.
if you don't have pellet, go to File and go to check for plugins. And it'll probably take a few seconds to come up. Then there's going to be a whole bunch of plugins here, and scroll down, and somewhere you should see pellet in there. So then you'll want to click on pellet and then click on install. And then once, however, to get pellet, to get it actually working, you're going to need to restart Protege. So before you do that, you're going to want to go to File and do Save, and save your ontology in some file. Then restart Protege so you have access to the.
Okay, thanks.
Got it?
Yes, thank you.
Okay, Michael.
Yeah.
So if you don't mind, what I
Yeah.
do in that case, since you have that ontology already up there, so I share my screen just to show that that how we are going to add those three classes, and then again
Sure.
I stop my screen sharing, and then again you can show the next level, right? So let me just then share my screen.
Okay.
Just to
So I've stopped sharing, so you can.
So that I do it like as it is, like from scratch. I'm doing it from scratch.
Okay.
And so my screen is clear to Michael. Is that quite clear, my screen? Or
Yes.
you so that's readable, right?
Yeah.
Okay, so let me just increase the font size little more. So 16. I think this gives, okay. So I'm going to the class tab, of course, as Michael is showing, so I will also do then from that tab. So generally I do from entity tab. Okay, so this is the class tab. And as already Michael said that, so this is the owl thing, that's the root node. And then you see there are three different icons you can see. One is now got activated, which says that add subclass. Then next to that we have add sibling class, and next to that we have deleted selected class, right? So we start with this because we want to add a subclass to this. So anything that we want to add here, all will be the subclasses of owl thing. This is the parent class is the owl thing, right? Now we click here, and say, for example, pizza, and this is one class is created now. And then say, for example, I want to create not the subclass of pizza, but the sibling class of pizza, right? So in that case, if we click again this will not work. So what we have to do, we can create here add sibling class. And so here, let us say the second class is pizza base. And yeah, so now I got the classes like Michael was showing, that pizza and pizza base. And then another is pizza topping, right, Michael?
Yeah, correct.
Okay, right. So then we can say it like this. And let's say I delete this class, and just I want to show you one more thing. By chance, for example, that while you were in pizza base, you just clicked on that pizza base and you created that pizza topping. And but you know that this is wrong because this cannot be a subclass, but you wanted to make it actually a sibling class. So what you can do, just you can simply drag and drop it under the wherever that you want. So in this case, under all things, so I just put it back, so it becomes the thing. So even if you do that mistake by chance, like instead of sibling class you have created a subclass, you don't have to delete and again recreate. You just simply drag and drop wherever you want. I think that was clear, right? So are there any doubts from the participants? Okay.
No, sir.
Okay, perfect. So then I stop again sharing my screen. So I think up to this was done. And one more thing, that as Michael already showed, that if we want to rename by chance, for example, if you want to rename it, so you can just do it by going to the refactor and rename your entity. Yeah, Michael, over to you now again. So you can share
Okay.
your screen.
Okay. Well, you know what, maybe I should just get rid of this ontology and do one. So I'm working at the same level as they are.
I request everyone, if you have any doubt or any question, please don't hesitate to ask us. We will try to answer.
Sir, what is the function of palette in the reasoner?
Sorry?
Palette, why you need to activate that palette in the reasoner?
Well, you'll see that in shortly.
Still, we have to go a little further, because right now that we cannot show the functionality of the reasoner with this right now. So just madam, please wait little more. So
Okay.
we need little more data inside, then only we can show the use of the reasoner.
Okay, sir.
Okay, so I mean, you can, if you want right now, although it's not really going to do anything, you can start the reasoner, and then you'll see it says reasoner active down here. So that means it's up to date with with the current ontology. So I just want to make sure. Okay, so the next thing we want to do is we want to make pizza topping, pizza base disjoint from each other. So to do that, we can just click on pizza and go to disjoint with, and then click on pizza base and do shift and click on pizza topping and click on OK. Okay. And then now run the reasoner, and you'll see that if you go to pizza base, it's all those disjoint axioms have been propagated to the rest of the to the other three classes. Okay, so now the next thing we're going to do is to enter the hierarchy for pizza base. So click on pizza base, go to tools and say create class hierarchy, and that's going to give you this window. And for the suffix, you're going to type in base because you want every class name to end with base. And I want to make sure I get these right. And so make that deep, pan, and thin, and crispy. And then it says you want to make sibling classes disjoint. I think, let me just double check. Okay, so yes, we do want to make those disjoint. So we just leave that checked and say
Sir,
finish.
please increase the size of your screen.
I'm sorry, you want me to?
Michael, Michael,
Yep.
you may increase the font size.
Okay.
Yeah.
Is that in preferences?
Yeah, yeah. Yeah,
General?
yeah. No, rendering you have to. No, so yeah, here in the
I
down
see.
font
Okay.
size. Yeah. No, let it be 16 and okay.
Okay, there we
I
go.
think it's better. I think now.
Yeah. Is that better? You should have this is what your hierarchy should look like now. And if it's red, if you need to run the reasoner, and then it won't be red anymore. Then the next one to do is to click on topping. So click on pizza topping and do the same thing. Go to tools, create class hierarchy, and then it's going to give you this. So you're, oh, it keeps on. Let's see. Sorry. That's good. So click here and click on tools, create class hierarchy, and then you want to model it on, do the same thing as what's in this this hierarchy here. So cheese, and then use the tab to indent. Oops. Okay, so that's what it should, your hierarchy should look like. Cheese, indented mozzarella parmesan, meat with ham, pepperoni, salami, sliced meat.
Michael,
Yeah.
Michael, we may wait. I mean, we can give a pause for
Okay.
for few seconds so that others can just type and at least couple of them they can type. They may not necessarily to add all of them, but maybe some couple of them they can add, and then we
Okay.
proceed. Yeah.
Okay. Oh, actually, I forgot to put as the suffix, for the suffix, make sure to put topping. Yeah. There we go. So let me know when you think I should keep going.
So Michael, while they type these subclasses, so I just wanted to add one more thing that I know that you have already said that, but by chance if anyone missed that point, see the disjointness is like it's good because Michael what he was doing actually that because that this functionality is available within our language, and so he discussed about it. But one thing I think we should mention that that disjointness is good to use only when that we know what we are going to do it, because it has a very strong consequences if we are not very clear that how it's going to be used. Then what will happen that if we do anything that after running the reasoner may complain that your ontology has a lot of inconsistencies. So the disjointness is a functionality that is available for us at our disposal, that we can use it, but we should know that when we should use and what is the reason that we are going to use it. Otherwise that may lead to a wrong conclusion. The reasoner may lead to a yeah. So
yeah, I actually that's a really good point. And I should emphasize that the reason I'm making these disjoint is because it's going to affect like reasoning further on down the tutorial. But my default when I'm building an ontology is, unless I'm really certain that things are disjoint, I don't make them disjoint to begin with. And I usually add the disjoint axioms as like the last thing that I do, because otherwise you'll get errors, and you can see, it's easier to see the errors in terms of like things getting classified incorrectly, as opposed to having the ontology be completely inconsistent. So I just want to reinforce what Biswanath said. I mean, in this is a particular case, we already know, what the end result is, and we know that for the purposes of some of the inferences we want further on down the road, we want these to be disjoint. But in general, I think it's a good idea to be very conservative about using disjoint classes when you're first building your ontology. Do you think I should keep going?
Yeah.
Yes, sir.
I think
Yeah,
yes, we
okay.
can proceed. Yeah.
Okay, cool. So just hit continue, and we're going to make these disjoint as well. So say finish, and run the reasoner. And so now you should see you have like this kind of a, make it bigger. You should see now you have this, your class hierarchy should look like this, or if you or as many of the classes as you decided to use. Okay, so now the next thing we're going to do is go to the object properties tab and click on the owl top object property. And we're going to first click on this thing, which is to create a subproperty, and say, call it has ingredient. And we're going to create two subproperties of this called has base and now here this UI is just like the class UI. So just like in the class UI, I use this to create a subclass and this to create a sibling class, a class at the next level. So it's the same with the UI here. If I want to create a property at the same level as this, the selected property, I use this. If I want to create a subproperty, I use this one. So I want, in this case, I want it to be the same level. So I'm going to use this one. And I'm going to call that has topping. And now I'm going to specify the domain and range. So for, and in fact, actually, so what we can do is for so for both of these, has topping and has base, the domain is going to be pizza. So we can go to has ingredient and we can just specify the domain here and go to this class hierarchy browser to specify the domain and click on pizza. Okay. And now if you run the reasoner, you should see that, okay, so it has topping and has base. Oh, crap. Sorry, I made a mistake.
You may stop the reasoner first. And
no, I made a subproperty there. There we go. Okay, so now has ingredient, I specified the domain as pizza, and now if I go to has topping, the domain is pizza, and if I go to has base, the domain is pizza. Now, but on I can't specify the range on here because what differentiates these two is the range. So has topping. Go ahead.
Michael, I see that again we give some few seconds pause so that they can type and they can run the reasoner and see the effect.
Okay.
So please create those sub properties and properties and sub properties, and then add the domain and run the reasoner and see that whether you are also getting the similar effect on your screen. And once you are done, maybe you can either unmute or and say that yes, it's done, or you can even put it on the chat box that it's done so that we can proceed to the next level.
Sir, how to add the domain? If you can please repeat.
Yeah.
Okay, so for the domain, you go to has ingredients, and then look in the description view. Oh, by the way, so just a quick thing about the Protege user interface. So these things are all called tabs, and then within each tab, each one of these is called a view. So like this is a view, this is a view, this is a view, this is a view, and you can customize the heck out of the interface. We'll do that later. But anyway, getting back to your question. So click on has ingredients, then go to the description and go to domain, click on that, and you'll see there's a bunch of different ways that a bunch of different tabs for describing what the domain is, but you're going to want to use the class hierarchy and click on pizza and then say, okay. Okay,
sir,
and
thank you.
okay, and then because has topping and has base, so this gets back to the person who was asking, you know, why are we using pellet? Why are we using the reasoner? So this is an example of why we're using the reasoner, because these two properties are sub-properties of has ingredient. Now, we didn't have to specify what the domain is. We just ran the reasoner, and it knew that the domain for these would be the same as the super property. So Biswanath, I think I'm just going to go ahead and just show them how to do the range too, because that's pretty straightforward.
Yeah. Please go ahead with the range.
Okay. So now so you're going to do the same thing for the range, but now because it's different for has topping and has base, you can't do it on has ingredient. Now you've got to do it on each one of these. So for has topping, go and click on the range here and click on the plus here, go again to this class hierarchy, or go to the class hierarchy and pick pizza topping and say, okay. All right. And you can do the same thing with the pizza base. Go to the range, click on the plus, click on pizza base and say, okay. And then synchronize your reasoner, and everything should be all set. And so the next thing we're going to do is we're going to create the inverse properties for this. So go back up to OWL top object property and click on the little icon here for creating a subproperty. And we're going to call this, remember the naming convention where we say has, has property. And then for the inverse, we say is property of. So we're going to call this is, because this is going to be the inverse of has ingredient. We're going to call it is ingredient of. Okay, and then we're going to also mirror the has topping and has base. So again, click on is ingredient of, click on the subproperty and say is topping of, and now we're going to select is topping of and click the one that creates you can see there's a little guide thing here that comes up when you hover over it. See, it says add sibling property over this, because you're creating it at like the same level. Whereas if you go here, it'll say add subproperty. So we want to create a sibling property. So we're going to click on that, and we're going to say is base of, say okay. All right, and now go to or actually, I guess I'll pause. Is are people sort of caught up? Anyone want me to any questions at this point, or anyone that's not caught up?
Michael, I think we can wait for a while here, and also if you kindly click on this has ingredient, I think would be good if you select that property so that they know that okay, so not yet, you haven't yet declared that inverse property, right? Okay, fine.
Right.
Okay,
Yeah.
right.
So
Okay.
that was the last thing I was going to do.
Okay.
But you want me to wait a little bit?
Yeah, just to wait so that they can type their own, and
sure.
then yeah. If you are done, the participant, please, any one of you, please let us know.
So one thing I wanted to point out, like a common mistake that new users make is they'll look at like the domain and the range here, and sometimes they'll want to say like it's two things. Like suppose I wanted to say the range for this, like suppose I was saying has ingredient, and I wanted to say the range was either pizza topping or pizza base. You might think to add pizza topping and pizza at like two different values here, but remember that this says intersection. So if you do that, what you end up doing is it's got to be both of those things, which is usually not what you want. So if you want to add two things as the range, the way you usually do it is to use the plus and then say like pizza base or pizza topping, and that will give you the union as opposed to the intersection, which is what you'll get is if you add two different values here. So on has topping, you can go and say now the inverse of this will give you a window that mirrors the current object properties, and then click down to is ingredient or is topping of. So we're going to say has topping. The inverse is topping of, and say okay. And the same thing for has base. We're going to say the inverse is base of, and say okay. And when you run the reasoner, then if you go to is base of, you can see that now both the domain and range have been filled in. And if I click here on the question mark, I'll get, this is the justification for why it's made that the range. It says because has topping is the inverse of is topping of, and has topping as the range pizza topping. So therefore, is topping of has the range of pizza. So, Biswanath, let me know when you think we should proceed.
Yeah. Is there anyone that are not able to do, or you have some doubt? Anything?
Sir, in my is topping of I have inverse it, but the domain and range is not being used by reasoner.
Did you run the did you do a synchronized reasoner? So go to reasoner and do synchronized reasoner.
Yes, sir. Still, it's not appearing.
Which reasoner are you using? Pellet, right?
Yes, sir.
And have you done exactly the way Michael showed you? Like, say, for example, base, that inverse, or say for each base of is the inverse of hatch base. Did you do exactly
yes,
the
sir,
same
I
way?
did that.
And so it's not showing this kind of inferred information,
Yeah.
right?
Yes,
That's
sir.
what you are saying.
And
But
can we?
Domain and range is not appearing.
Is it possible for her to share her screen?
Yes, so I have to make her, let me make her co-host for the time being. Okay.
Should I stop my, I'll
No,
stop.
no, that's okay. So you can
Okay.
remain there, no problem.
Okay.
Let me, Shushmita, I see your two entries. Which one you are, that with the photo or with the some SB? Shushmita? Okay, Sushmita, you may share your screen. Hello? Sushmita, can you hear us?
Sir, I'm not able to share.
Maybe I need to stop sharing.
No, okay, yeah, but that's okay. She can do the, okay, you can stop your sharing. Okay, fine. It's maybe because you were already, yeah. Now you try.
Sir, actually,
Yeah, it's coming, I think.
SB is the one which need to be hosted,
Huh?
not the photo one.
Oh, okay. Okay. Remove co-host permission. Okay. Now you see. Yeah.
Okay, good.
Yes, sir, this one. I've made it this one, but it's not.
Go to reasoner. Okay. Maybe you stop it once and restart the reasoner. Come to this hedge stopping. Okay, it's there, but it's not coming there. Okay. But I think this is more to do with the interface, because I know that this depends sometimes, you know, sometimes it doesn't show on the screen. So which version are you using?
5.5.5.0.
Okay. No, in sometimes this happens actually. This is nothing new, that on the screen you don't see on the interface, but when we add the data and then we see the inferencing is working. So it may be that's the issue. What about the others? Is there anyone also have the similar result?
No, sir, it's fine.
It's fine. Okay, so it's sometimes that, Michael, this happens. Even I also earlier experienced. I mean, sometimes we face the same problem in the class also. That I don't know. It's sometimes I think it's operating system. Sometimes this particular version.
Well, I have noticed. Well, yeah. Okay. Can you how can you click on has topping too? I'm just curious. Okay, and so that's not, and then that's not working either. The inverse is topping up. Yeah, that's weird.
But you see that, yeah, so each base of inverse of hedge base, so it's there, right? Now, Sushmita,
Yeah.
come to that hedge base, click on hedge base, and here it's showing that is, so that at that level it's working. And I hope that, Sushmita, you didn't explicitly mention for both the properties like inverse of inverse of. How did you do?
I just hear from here. Inverse.
No, just okay. So you created for hedge base that inverse of each base of, right?
Yeah.
And
yeah,
you
no,
did,
that looks right.
and you, I hope that you didn't do again the same thing for each base of and inverse of hedge base, right?
No, sir.
Okay,
that I
perfect.
didn't.
That's fine. That's the way it should be. Okay, good. But then I think it's just the matter of the screen, because you see that the reasoner is able to, you know, identify that this hedge base is inverse of each base of. So that means it's working. It's only the domain and range are not, you know, shown. on the interface, but I think that should be okay. Sometimes this happens. So I think we can move on.
Okay,
Okay.
all right. Yeah, sorry about that. I mean,
No,
I've seen it happen. Well, anyway, it doesn't matter. I mean, I think it's obviously a bug in, are you working on Windows or on the Macintosh?
Windows.
Okay, huh. Do you have, sorry, do you have any like Java environments loaded on your system?
Yes, sir.
You do. Okay, that might be the problem. Sometimes there's conflicts between, now there shouldn't be, but like I had this happen, and it was the same kind of thing where properties weren't things weren't getting propagated, because in my case I had Eclipse loaded, and I had the JVM for Eclipse was interfering with the JVM for Protege. So it may be that the whatever Java environment you have is interfering with the Java environment in Protege. That's not supposed to happen, but that's a bug. Sorry about that. But anyway, I guess we should keep going.
yeah.
Yes, sir.
No.
Okay, so the next thing we're going to do is add a restriction to the pizza that specifies a pizza must have a pizza base. So we're going to go back to the classes, and we're going to click on pizza, and we're going to add an axiom here, subclass, and use the object restriction creator, and say it must has base, and we're going to, the restriction type is sum, and we're going to say pizza base. Okay, so click on that, and that will create a restriction here. So we're saying that all pizzas must have a pizza base. Now remember, this is a necessary condition, but not a necessary and sufficient condition. And you click on the reasoner just to synchronize it. Okay, so now the next thing we're going to do is we're going to create subclasses of pizza called named pizza and margarita pizza. Okay. So first of all, go to pizza, and we're going to click on this one, the one that says add subclass. And we're going to call that named pizza. Okay. And we're going to create a subclass of named pizza. Again, create another subclass called margarita pizza. Okay. Now notice that it's red here. That's just because I haven't run the reasoner, so the reasoner is not sure if this is a valid definition or not. So when I run the reasoner, and you'll notice it's a little red here, you can get rid of that just usually by expanding and contracting it, or also another option if your interface ever, the other, I don't think this will work, but the person who was having trouble with the domain and range, this is another thing to try. In your case, I don't think this is going to work, but you can do refresh user interface. So if your interface ever gets to a point where it seems like it's not looking correct, you can use this option is a good option to try. Okay, so now we're going to define some more axioms on margarita pizza. And so we're going to click on subclass of, and this time instead of using the object restriction creator, we're going to use the class expression editor. And we're going to say, just want to make sure I get it right, has topping some mozzarella topping. Okay. So we're going to do, now here's an interesting, so just type HA and then hit control space. Okay, and so you see that now it's giving me all the possible completions of HA. So I'm going to say, click on has topping, some, and then I'm going to type MO, and and then I hit control space again, and then it completed, because after I typed MO, the only possible completion is mozzarella topping. So in any of the user interfaces, whenever you're entering like this, so remember I was talking about description logic. So this is an example of a description logic axiom. Whenever you're adding a description logic axiom, you can always hit control space, and it will either give you a menu of all the possible completions, or if there's only one possible completion, it will complete it for you, which is what it did here with mozzarella topping. Okay, and also when you're in this this editor, the class expression editor, or in fact any of the editors like this that are similar, it will only let you do okay if the syntax is valid. So like if I said has mozzarella toppings, see, now notice that it's grayed out because there's no class called mozzarella toppings. And also it highlights this in red because that's the problem. So I get rid of that and I say, okay. And I'm also going to add another topping. And you'll notice I just type H and it completes to the last thing that I typed. Now, in this case, though, I don't want mozzarella topping, so I'm going to get rid of that. And I'm just going to say TO and then hit control space, and it says tomato topping. Okay, and then I say okay, and run the reasoner to make sure everything's cool. Okay, is anyone still working, or should I go ahead? Okay, I'm gonna continue then. So the next thing we're gonna do, we're on exercise 16. We're gonna create Americana pizza by cloning margarita pizza and adding additional restrictions. Okay, so click on margarita pizza and go to okay, well, hang on. Edit. Okay. Click on that. Go to edit, and I see. So go to click on margarita pizza. Go to the edit window, and then click duplicate selected class. So because we're going to create a new class that's very much like a margarita pizza, so we're going to use the definition of margarita pizza as a starting point, and then we're gonna change it somewhat. So now it asks me to come up with a different name because there's already something named margarita pizza. and I'm going to call it Americana pizza. Okay. And we're going to add to these toppings here. We're going to add pepperoni. And so I type PEP and I hit control space. And now since there's two here, it could be pepper topping or pepperoni topping. I'm going to click on pepperoni topping, and that's what I want. And notice it says equivalent to all nothing here. That's because I haven't run the reasoner. So I'm going to synchronize the reasoner, and now that goes away. And so now I've got a new class. Oh, so one thing we can do, people were asking about annotations. So this window here is where you add annotations for a class. If you go to object properties, you can add annotations for a property here. So if I wanted to add, say I wanted to add an annotation to is topping of, I would go here, and then here's, this is the list of annotation properties that come that come by default with Protege. You can create your own annotation properties as well. So I could add a comment here like whatever. So that's an example of doing annotations. Okay, so now we're going to, again, duplicate the class Americana Pizza, and we're going to add something to it. So click on Americana Pizza.
Michael?
Yep.
Sorry, one thing. So can we? I think we can show here also the this deprecated, that how it actually looks like. Say for example, just we show it like American pizza is a deprecated class. And then we say, just show it on the screen that how it looks like. So
I'm not sure.
Okay. So what I'm saying, that maybe we show one annotation that how it affect, how it basically looks like if we use that.
Oh, you mean add an annotation to a class?
Yeah.
Yeah. Oh, sure. Okay. Yeah, no problem.
Maybe we
So,
add
for
one,
example, if I wanted
will
to,
help. Yeah.
if I wanted to add an annotation to Americana Pizza, I would just go here, click on the plus thing next to the annotations. So that gives me all the other. So you can see, these are all things that have to do with some metadata kind of things, like backward compatible with deprecated, which I mentioned before, which means it's going away. It's not going to be supported in future versions. And of course, the one that's most common is comment. And so I'll just say created by cloning margarita pizza. And adding pepperoni. And I just say, okay. And then you can see here, the comment shows up in the description of Americana pizza. So if I click on margarita pizza, comment, if I click on Americana pizza, I can see here's the annotation comment that I created. So now I'm going to go to click on Americana Pizza, do edit, and do duplicate selected class. Again, I have to provide a different name, and I'm going to call this Americana Hot Pizza. And I'm going to add the to Americana Hot Pizza. I'm going to add the topping. So I type JA and then hit space, and it completes to jalapeno pepper topping. So I hit OK, and then I run the reasoner. And I'm also going to create Soho Pizza by cloning Margarita Pizza. So again, click on Margarita Pizza, go edit, duplicate selected class, and say Soho Pizza. And a Soho Pizza is one that also has olives. So I start has topping, then I can delete the jalapeno, which was the last one. Just type OL, and hit Control Space, and it completes the olive topping. And then I synchronize the reasoner again. Okay, so we're going to make all the subclasses of named pizza disjoint. So to do that, we can just click on any one of them. Let's go. So notice first of all that Margarita Pizza is already disjoint with pizza base and pizza topping. The reason for that is that it's a subclass of pizza, and pizza is disjoint with pizza base and pizza topping. So that means that all of its subclasses are also disjoint. But now I want to make all these sibling classes disjoint. So I clicked here to add another axiom, and I can go here, go to name pizza, and I can click here, hold down the shift key, and click all these three and add them here, and then run the reasoner. And we can see now it's been propagated to all the sibling classes. So any questions so far, or is everyone keeping up? Okay, so now we're gonna show an example of the reasoner detecting a class that can't be satisfied. We're going to see. Sorry, it's been a while since I wrote this, so I have to make sure I'm remembering correctly. Oh, I see. Okay. So we're going to click on pizza topping and create a subclass. So click on pizza topping, go here again. Remember to create a subclass, and I'm going to call it probe inconsistent. Pardon my spelling. There, and then we're going to go, let's see. I see. Oh, I see. Okay, okay. So we're going to make this a subclass of oops. Yeah. We're going to make this subclass first of cheese topping. Okay, and then we're going to also make it a subclass of vegetable topping. Now, you notice that I ran the reasoner. Actually, I'm going to do. Oh, right. It's yes. So it's the reasoner is highlighting this class now as being in red. And notice that it says equivalent to all nothing, which means that this class can never have any instances. And if I click on the inferences, it says that I made it a subclass of cheese topping and I made it a subclass of vegetable topping, but those two classes, cheese topping, it says that then it lists these are all disjoint classes, and which includes cheese topping and vegetable topping, which means therefore it's a class that can never have be satisfied, because I've declared that cheese topping and vegetable topping are disjoint. So therefore, this is equivalent to the empty set or to all nothing, because nothing can ever be an instance of it, since it's a subclass of two different disjoint classes.
So, Michael,
Yep.
Before we further proceed, so we can do one thing. So almost like we are at the end of this our lab session 2. So what we can do, we can take a quick break for 10 minutes, 5-10 minutes. Like so,
Okay.
as per the schedule, like from 3:30 to 3:45 is the break. So
Okay.
what we can do, we can probably before we go for break, we can take couple of questions if they have anything from this session. And
Okay.
if there are no questions, so we let the the participants to try by their own in this break session if they wish. And then we come back after the break, and then we go to the next level of discussions, right? We proceed with the other features that you would like to demo, right?
Okay.
So I think.
Yeah. And by the way, if you want to stop at any point and go into the documentation stuff, just let me know. I want to make sure we have time to do that.
Sorry, I didn't get you.
Oh, I said if you as we're going, if you want, I want to make sure we have time for you to show the how to do the documentation thing.
Yeah, that's okay. So because that the lab session 3, we have 2 hours time.
Okay.
And I think that's okay. Sometime we can keep it for the, at the end of the next session, we can keep some time for the documentation. That should not be a problem, I think.
Okay, awesome.
Right.
All right.
Yeah. So yeah. So all I request you to, of course, whoever wants to stay back, you can stay back. But anyone wants to go back for kind of couple of minutes break, So you may proceed, and if anyone wants to stay back and ask questions, want some clarification, so you may proceed for the that kind of doubts, and we can ask. Okay. Are there any doubts? No. So it seems they are all doing great. So
Sounds good.
and all the credit goes to you only. So because you are able to make them really to do things. So that's great.
Sir, owl nothing, that part you can show again.
Yeah.
Go ahead.
The last part, yes.
You want me to redo the last part?
Yeah, owl nothing, how it works.
Okay. So you create a class. So here, I'm going to delete this. Okay. So create a subclass of cheese topping. So click on cheese topping and then use the add subclass icon up here. Okay. And click on that. And let's just call it this time, let's call it bad topping. Okay, so it's down there. Now go to, now actually if you use the reasoner now, it's okay. Okay, it's not red or anything. It's a well-defined class. But now go to a subclass of and add vegetable topping as another subclass for bad topping. Okay, now if you run the reasoner, you see that it's highlighted in red and that it says that it's equivalent to owl nothing. And if you click on the question mark, the explanation generator, it tells you that it's a topping, it's a subclass of cheese topping and vegetable topping, but those two toppings are disjoint classes. So that's why it's a ill-defined ill-defined class that can never be have any.
Yeah. So
Yes, sir.
Yeah.
Is that
So
clear?
this.
Yes.
Okay,
Yeah, so
great.
this exactly, it shows that why disjoint classes are kind of, it has a very strong consequences, because you see this, like in one place we are defining that they are disjoint classes, but then we are saying we are creating a class which made them as the subclasses of them at a time. So that's really inconsistent, because in one side you are saying that a member of a class, one member cannot be the member of two different classes at a time, and on the other side you are actually asserting the same thing. So you are basically contradicting what you said earlier. So that's the that's why it's very kind of dangerous, because sometimes you may not realize that issue and you will find that your ontology is inconsistent. However, one thing that I observed, Michael, that this like 4.0, Protege 4.0, it was really very difficult to debug that. But it's good that with this improved reasoner, I think this credit goes to the reasoners, especially Pellet kind of the reasoner, that actually it tells you that where actually it went wrong, and that's good. At least you can debug it. So that's the advantage still we have. So provided that we know that how to debug, how to read that reasoning, the logic, then
Right.
I think we can resolve that problem. But it was not the case with the earlier versions of Protege, like Protege 4.0 or even before 3.0. We had really that issue. I know that in my when I started first doing these things like a decade ago, and I really used to face that challenge. And that sometimes it happened, I had to scrap my entire ontology and
Yeah.
redo the things, and I don't understand that where we went wrong. So
Actually,
Sir,
go ahead.
yeah, please go ahead.
I have made some disjoint classes. Do I can make it like back or removing them?
Can you remove? Can you say that the classes are not disjoint?
Yeah, they are not the
Yeah. Of course. I mean, to do that, all you need to do is on all these. So these are all anything here. These are all called axioms. Okay, and on any if it's highlighted in yellow, it's an axiom from the reasoner. So you can't edit it, obviously, because it's an inference from the reasoner. But if it's not highlighted in yellow like this, then it's something that was defined by the user, so you can edit it. So or you can edit it or you can delete it. So if you wanted to delete all these disjoint axioms, you could just click on this X, okay, and that would delete this entire axiom here. Or if you click, and this is for any axiom, you click on the little circle at the far right for any user supplied axiom. It will give you an option. It'll tell you here's what it currently is, and if you want to change it, like so, if I wanted to just say olive topping and tomato topping, for example, are disjoint, I could do that, and then I would change the axiom. Is that what you were asking, or is it still not clear?
Yes, it's clear.
It's clear. Okay, good. One other thing I wanted to say, in addition to what Biswanath said, is that that's a reason why I think it's really a good idea to run your reasoner often, because another thing that will happen is, and I've seen this happen with so many new users, that they make a lot of changes without running the reasoner. Then they run the reasoner, and it turns out that there's not just one thing that's causing an inconsistency, but maybe 2 or 3 or 4. And if that happens, it's much harder to debug what the problem is than if it's just one problem. So, if you run the reasoner after almost every change, then as soon as you get an inconsistency, you know that the last change you made is what caused the inconsistency. If you wait until you make like 10 changes and then run the reasoner, it's not as clear, and there may be more than one thing that is causing the inconsistency. That's why I really recommend people run the reasoner often.
Yeah, that's right. Yes.
Oh, Biswanath, are we taking a break now?
I really don't know, because I see all the participants are still here. So I think since all are keen to continue, so in that case possibly we can continue, because of course we had in between this some I think useful discussion. So I think we can proceed. Unless the participants say anything. Is there anyone that who wants, like, still we should wait for a couple of minutes, or it's fine that we proceed?
It's fine, sir.
Okay, fine. So Michael, I think we can proceed.
Okay.
Perfect. Thanks.
Okay, so the next thing we're going to do is create a class called Cheesy Pizza, and to do that, click on pizza and click on the add subclass and say Cheesy Pizza. And okay, good. That's what I thought. so we're gonna add the axiom. In fact, we can just edit this, which is subclass of pizza. So click the little edit window here, say, and go to the class expression editor. Let me go through that one more time, just so people know. Okay, so so go to pizza, click on the subclass, and then call it cheesy pizza. And now we've got a subclass of pizza called cheesy pizza. Now go to the subclass of, in the description of cheesy pizza, and click on the little circle here. And don't use the class hierarchy, use the class expression editor, and say pizza, and whoops, and has T, and then you can hit control space, topping, some, and you can actually, some, CHE, and then I'm going to hit control space and say, so I'm going to, so a cheesy pizza is a pizza that has topping, some cheese topping, and then hit OK. So far so good. But now, remember I was saying, so far all of these are primitive classes. Remember, so all these are just necessary conditions. They're not necessary and sufficient conditions. So I want to make cheesy pizza be a defined class, and I want it to be necessary and sufficient condition. And so to do that, one way to do that is I click on cheesy pizza and I go to edit and I say convert to defined class. Okay, I'm going to do that one more time. So you've entered on cheesy pizza, you've entered the axiom pizza and it has topping, some cheese topping. Then you go to cheesy pizza and you go to edit and you say convert to defined class. Okay, now you'll notice that it's moved the axiom up from the subclass of to the equivalent to field. And now I'm going to run the reasoner. And I think, okay, so now you can see here, now this is an example of the reasoner. So this is, and so in this classes tab, you have two views. You have the class hierarchy as defined by the user, and then you also have the class, which actually this is the real class hierarchy, the class hierarchy that has been inferred by the reasoner. And up until this point, I wasn't looking at this because they were actually both the same. But now you can see that since I said these are necessary and sufficient conditions, and since all of these pizzas have cheese topping, it's the reasoner has inferred that they're all subclasses of cheesy pizza. Is that any questions on that?
So I think we let them to do things.
Okay.
Yeah, Gargi ma'am has some question.
Sir, what was the difference between those two classes? Like when he create the inferred classes, what was the difference? I did not get that.
The difference between the cheesy pizza and the other classes?
No, after this, the inferred classes and the previous one.
Okay. So the difference is this view is the view of what the user has defined. Okay. This view, you notice it says, this says class hierarchy, this says class hierarchy inferred, and you'll see there's a lot of examples of the user interface where it will say, something, and then it'll also say there'll be another view that says something inferred. And when it says inferred in parentheses, what that means is this is the class hierarchy as inferred by the reasoner. So in what I defined, I didn't define any subclasses of cheesy pizza, but because of the way it's defined, because of the axiom, the reasoner is able to infer that all these other pizzas are actually subclasses of cheesy pizza, even though I didn't actually, as a user, I didn't actually define that. All I did is I defined the axiom, and the reasoner inferred based on those axioms, based on that axiom, and then the axiom of these other pizzas, which all have a cheese topping, that these are all subclasses of cheesy pizza.
Okay, sir.
Does that make sense? Okay.
Yes.
Good. Excellent. And so, this is an example of what I was talking about, like the kind of things that were first done with KL1, where you would, instead of defining your class hierarchy manually, you would give it a bunch of logical descriptions, and it would infer the class hierarchy for you. So this is an example of doing that, where the reasoner redefines the class hierarchy based on the logical axiom given. So next, we're going to create a defined class called vegetarian pizza. So we're going to go back. We're going to go back to the user view and click on pizza, and say add subclass. So add another subclass, and we're going to say vegetarian pizza. Okay, and now we're going to go and do the same thing. We're going to edit the subclass of definition, and this time we're going to say pizza, and let's see, I want to make sure I get it right. And so instead of some, we're going to say only cheese topping, or, so I type VEG and I type control space, and I select vegetable topping, and then I close my parentheses. So now I'm saying, so remember, this is saying the sum says that it must have, there must be an instance of that class. The only says that the only, just what it says, the only possible instances of the topping can be either cheese topping or vegetable topping. And so now I'm going to say, okay. And I'm going to do the same thing. I'm going to go to edit, and I'm going to say convert to defined class. And then I'm going to run the reasoner. And now I'm not sure if that has, yeah, no, there's no vegetarian pieces yet, but okay. So here's an interesting question. So if I look at margarita pizza, it looks like it's a vegetarian pizza, right? Because it's got cheese and it's got a vegetable, and that's all it's got. So you would think that it should be a subclass of vegetarian pizza, but if I look here, it's not. And the reason it's not, and this is something that is one of the harder things to understand about OWL, and I'm going to talk about this more in one of my presentations later on, but something called the open world assumption, okay? So normally, like in databases or a programming language, if you don't have some information, you know, you assume, a better way to say it is, you assume that everything that can be known about the system is known about the system. But because this OWL was designed for the internet, you know, which is an open system, they use what's called the open world assumption. So the normal way of reasoning in a programming language or a database is called the closed world assumption. Closed world meaning that everything that that the system knows is already in the database. The open world assumption says there may still be things that we don't know that are out there. So even though the Soho pizza has toppings, it has only vegetable toppings and cheese toppings. I haven't said that it can't also have other kinds of toppings. Because it's only necessary conditions. And so what I need to do is what's called adding a closure axiom. In other words, I need to say that these are the only toppings that can be actually on margarita pizza. And I know this may be a little confusing. This is one of the harder parts. So don't worry if you're not, if this isn't completely clear. Hopefully it'll be clearer when I do another talk later on. So I want to go to right. And I want to say only right, mozzarella topping or tomato topping. So now we can see that margarita pizza is classified as a vegetarian pizza, because I said not, because before I was just saying it has these toppings, but I wasn't saying that it couldn't have any other toppings as well. But when I add this axiom that says only as opposed to some, now I'm saying these are the only toppings that it can have, mozzarella and tomato. So therefore, now the system knows that it's a subclass of vegetarian pizza. And I'm going to do the same thing for Soho pizza. And I'm going to cheat because I copied it from the tutorial because I didn't feel like. Oops, wait. Oh, I see. Okay, so I'm doing the same thing for Soho pizza, where I'm saying not just that it has mozzarella, olive, and tomato, but it only has those. Those are the only toppings that it has. It can't have, essentially, I'm guaranteeing that it can't also have like a pepperoni topping or a ham topping, which would make it not a vegetarian pizza. So I say okay, and then I synchronize the reasoner, and then when I go to the the inferred class hierarchy, I can see that margarita pizza and Soho pizza are both under vegetarian pizza. Are there any questions on that? Okay. Does anyone need some time, or can I keep going? Okay, I'm going to keep going then. So the next thing I'm going to do, now remember, I talked about how you could have an implicit definition of a class or an explicit definition of a class. So everything we've been doing so far has been an implicit definition of classes. So we're giving these axioms, but we're not actually specifying the specific individuals that are in the class. Now I'm going to do something where I'm going to create a defined class where I do specify the individuals, and this is called an enumerated class. So to do that, first I go all the way up to thing again, and I click on thing, and I click on subclass. Okay, and I'm going to call this new class spiciness. Okay, now I'm going to create now the first instances in the ontology, and I'm going to create 3 instances of the spiciness. So I'm going to say, so to do that, sorry, I go to, so I've got spiciness, let me just synchronize the reasoner. So I've got spiciness selected, and then now I go to instances, and I click, notice the little prompt window that comes up that says add. So I click on add, and now this is giving me a window to add instances of spiciness. So to add them, I click on the little diamond here and say add an individual, and I'm going to call that hot. And I'm going to create another one called medium. And then I'm going to create one more called mild. Okay, and I say okay. Now this is actually something about the Protege user interface that is not all that great. You would think that all those instances would be instances of spiciness, but for some reason it just makes one of them instances of spiciness, but that's okay, because now what we're going to do is we're going to go to the equivalent to we're going to make spiciness a defined class, but now instead of making it an implicitly defined class the way vegetarian pizza and cheesy pizza were, we're going to make it an explicitly defined class. So we're going to make an open bracket, which is, that's the way we specify a set, and we say hot, comma, and we can also do control space, medium, and mi control space mild, and then we do close curly brackets. Okay, and now if I do run the reasoner, so now so notice that before mild was the only instance of spiciness, but now that I've used it up here, the reasoner knows that hot and medium are also instances of spiciness. And so these are the only possible instances of spiciness. So when we have this is called an enumerated class. And this is often useful, you know, when you have like keywords that you use rather than using strings. It's often better to you know, if you have a small number of values like hot, medium, mild, it's often better to create individuals rather than have them as strings, because there's a lot of things that you can do automatically with the reasoner knows more about individuals than it does about strings, and you can do things more automatically with when you actually have them as named individuals than you have with strings. And you'll see an example of that when we go to write some rules in Swirl, that we're able to automatically take advantage of the fact that these are individuals rather than strings that indicate hot, medium, or mild. So so now we've created this class, and we've given it a definition. Are there any questions on that?
Participants, if you have any question, you can ask now.
Okay, so now we're going to, we want to be able to specify the spiciness of our toppings. And so we're going to go into the object properties up here, and we're going to create a new object property. So click on OWL top object property, and then click on the little add subproperty icon, and call this has spiciness. Okay, and so let me just check. Right. So the domain for this is going to be so to specify the domain for has spiciness, go down to the description window and click on the domain little plus icon, and then you can go to the class hierarchy and select pizza topping, because the pizza toppings are the things that have a spiciness. And for the range, I think that's obvious. Click on that. Click on the range, and you choose spiciness. Okay, so now we're going to go to right. We're going to go to jalapeno pepper topping, and we're going to add an axiom that says so just type has S and then hit Control space. And now, so far, we've been using some and only, which are like, which describe generalities. So some means there is some instance of this class. Only means there can only be instances of this class. But here, we're going to specify a specific value. So we're going to say a jalapeno pepper topping has spiciness whose value is hot. Okay, and you can see that now it says okay, and I'll say okay, and then run the reasoner. Oh, I see. Okay. Okay, right. So now we're going to create. So is that clear? Any questions? So, okay. So next we're going to create another defined class, a subclass of pizza. So click on pizza and click subclass icon, and we're going to call this spicy pizza. Okay, and we're going to just go and type, and we're going to do the same thing where we edit the subclass of and say pizza and okay. Okay, so we're saying that a spicy pizza is a pizza and it has some topping. And I know this is a little confusing, but this is when you have, when you're trying to do sort of chains of axioms, like going from one thing to another thing, you have to, this is the way you have to do it. So it's saying a pizza that has a topping that has some spiciness whose value is hot. So, I mean, this is, it's not the most intuitive in this case, but it's essentially saying that it's a pizza that has a topping whose spiciness is value, has a value that's hot, is a spicy pizza. So I'm going to say okay, and then I'm going to go to edit, and I'm going to convert this to a defined class. And I think wait, what the heck? That's interesting. Oh. Oh, maybe. Okay. Huh. All right. Something. Sorry about that. Okay. I'm not sure what was going on there, but there was some. But anyway, this is what it's supposed to do. Spicy pizza is a pizza that has a topping that has a value, spiciness value that's hot. And when I go to the class, this is the class hierarchy inferred. I see that Americana hot pizza, which has a jalapeno pepper topping, and if you remember that when we went to jalapeno pepper topping, we said that it has spiciness value hot. So therefore, since Americana hot pizza has a jalapeno pepper topping, and because a spicy pizza is a pizza that has some topping that has a spiciness that's hot, the reasoner infers that Americana hot pizza is a subclass of spicy pizza. Any questions on that? Okay, so the next thing we're going to do, and I mentioned this in the in one of my talks, is we're going to create a defined class called interesting pizza. So this is a pizza that and has topping min 3. So an interesting pizza is a pizza that has 3 or more pizza toppings. And I'm going to say, okay. And I'm going to do my usual convert to defined class and run the reasoner. And then when I go to my class hierarchy inferred, I see that these are all my interesting pizzas that have 3 or more toppings. Okay, is that any questions so far? Okay, so the next thing we're going to do is we're going to add a data property. So far we've been just doing object properties. Now we're going to do data properties. So to do that, we can go to Windows, tabs, and select data properties. And that'll give us a tab here. So I'm going to select, and so this is just like, so just as with object properties, everything is a subproperty of all top object property. With data properties, everything is a subproperty of all top data property. So, and it's the same thing here with, you do this to create a subproperty, you do this to create a sibling property, and you use this to delete a property. And we're going to create a subproperty called has caloric content. And the domain for that is going to just be a pizza. And the range, let me just double check. Okay. And for the range, we're going to make the range an integer. So click, so I should probably do that more slowly. So I specified the domain just the way I would specify the domain for an object property by clicking here and then by selecting pizza from the class hierarchy. And now I'm going to specify the range, but since this is a data property as opposed to an object property, it's going to look a little bit differently. So I click on range, and now that gives me two things. This here, if I want to create a certain data range expression, I can type it in here, but usually you don't need to do that. Usually just use one of the built-in data types. And so the one that we want is XSD integer, because it's going to be an integer value. So we do okay, and we synchronize the reasoner. Okay, and now we're going to oh right. So also one other thing is we're going to make this functional. So because, and usually, or not, I often, your data properties are often functional. Not always, but a lot of the time. So, you know, functional means the same thing as it does in mathematics, which is so a pizza can only have at most one value for its has caloric content. It can't have functional. Functional is the same thing as saying maximum of one value. And so I'm going to synchronize the reasoner. Let's see what else. Okay, so the next thing we're going to do is to customize the protege user interface, because now we're going to start creating some new individuals. So to do that, well, actually, so yeah, to do that, we go to individuals by class. Now, unfortunately, your interface is not going to look like mine because I've already tailored mine, but I'm going to delete this. Okay, so now, so go to, actually, if it's not open already, go to Windows, tabs, and go to individuals by class. Okay. Oh, I think I just got rid of it. Okay, so then go to individuals by class. Now we want to add a view. So remember that all these things are called views. So like each one of these little panes, little subparts of the user interface are called views. So we're going to add a new view to this particular tab. So to do that, we go to Windows, Views, and this is going to be a view to view individuals. So we go to individual views, and we go to individuals by type inferred. Okay. So again, go to Windows, Views, Individual Views, and Individuals by Type inferred. Click on that. Now that's going to give me this little thing, and you'll see, like, as you move it around, it looks different shapes. That's the shape it's going to take within user interface. So like I could, if I wanted to, I could add it here. So like if you add it so that it takes up, see how it takes the whole frame for this particular pane. That means it's going to add it as another sub tab to this set of tabs. So that's what I wanted to do. So I'm going to click on it and see, now you can see individuals by type inferred is part of my user interface. And you can see that we got the three individuals that we created earlier of spiciness, medium, mild, and hot. Any questions on that? Okay. Okay, so now we're going to create a pizza. We're going to go to while you're still in this user interface, click on Margarita Pizza, and then you'll notice down here it says direct instances. And if you click on the little diamond, notice you get the little window that says add individual. So I'm going to click on that, and I'm going to say call it Margarita Pizza 1. And I'm going to run my the reasoner. And so now you can see that in this view here, now I've got, besides the 3 individuals of spiciness, I've got 1 individual of margarita pizza. And as you keep on adding individuals, you'll see them showing up here under the particular class that you want. That's why I like this view, because when you have a lot of individuals, it's a nice way to have them, group by the specific class. There's another view you can use, which is just called individuals, that just lists all the individuals, but here it doesn't group them by class, which is not a big deal because now we've only got a handful of individuals. But when you start getting hundreds or even thousands of individuals, it's nice to have them grouped by class the way this is. Okay, so now we're going to do our first time of setting a property value. So we're going to go click on Margarita Pizza, and you should see down here it says property assertions for Margarita Pizza 1. And we're going to go to data property assertions and click on add. And that's going to give us a window with all of our data properties. We only have one, has caloric content. We want to specify the type to be XSD integer, because that's what we said the range was. And we're going to put in some value. I'm going to make it 263 and say OK. So now we've got the caloric content for margarita pizza specified as 263. So we can create. So now at this point, just create a few more instances. Actually, I'm going to make it just a couple. So I'm going to click on Americana Pizza and click on create and call that Americana Pizza 1. And I'm going to specify the caloric content of that to be much higher, like 723. And let's see, I'll just create like also an instance of Soho Pizza, call that Soho Pizza 1, and give that, let's say, 320. Okay, so now we're going to go back to the classes tab and click on pizza and add a new restriction that says, and here we're going to use the data, we can use the data restriction creator and say that has caloric content some XSD integer. Okay, now we're also going to right. Okay. So we're going to create now another defined class, subclass of pizza called high calorie pizza, and say pizza and has just put C and then type control space, caloric content. So has caloric content, some XSD, some integer, XSD integer, and then this, so bracket, open bracket. Actually, I want to make this greater than 400. Open bracket, greater than 400, close bracket. So this says that a high calorie pizza is a pizza that has caloric content that is an integer and is greater than 400. And I'm going to convert that to a defined class. Why does there we go. Great. Okay, so and so you can see that what the reasoner has done is it's inferred that Americana Pizza 1 is an instance of high calorie pizza because it has a caloric content that's greater than 400. Okay, so we're actually almost done. The last thing that we're going to do is we're going to create an order on, or actually, so I should stop. Any questions so far? I know I've been going kind of fast now. Okay. So we're going to create two more properties. We're going to create an order for the spiciness individuals. So I'm going to create a sub property called is spicier than, and I'm going to create another property called is milder than. And so on is spicier than, I'm going to say that it's transitive and it's its domain, its domain and range are both spiciness. And it's the inverse of is milder than. Okay, and so now if I go back to my individuals by class and I go to spiciness and I go to hot, I can say is spicier than medium. And again, remember you can use control space. And on medium, I'm going to say is spicier than mild. And it does this every once in a while. It jumps for some reason. It jumps you into the property editor when you're editing values, but it's not a big deal. Right. And now I think, right. So now you can see, so I only specified two things. I specified that hot is spicier than medium and that medium is spicier than mild. And because these are transitive properties and because they're inverses, the reasoner was able to fill in all the other appropriate property values for me. Great. So Biswanath, I think that's about it. That's as far as I had planned to get in the tutorial for tonight. Do you want to take over and do the documentation stuff?
Yeah. So yeah, let's see that whether the participants have any questions.
Oh, sure. Of course.
So participants, do you have any questions? You want something to be explained, you can ask. No? Okay.
Sir,
Yeah, please.
in the integer part, data integer part, I think data properties, you used greater than formula, like greater than third bracket greater than 400. So for that, we did not need any like any other function for that, or we only need to write like it is an integer, and that would work like that way.
Yeah. Yes. That's all we needed to do. I'm not sure I understand the question.
Maybe you can go once again to that.
Yeah. So high calorie pizza. So it says.
Yeah, is the greater than. So like we only use that XSD color integer. Those only we need to write, or any other function you need to
No. But just to be clear, though, this is not. So this is not a function, and you know that's there's no functions. You know, this is a purely a data definition language. So but this is just a logical axiom that says that it's this property this property has Florida content must have a value which is an integer, and that integer must be greater than 400. Okay, so it's not a function call. It's just a logical definition that the reasoner takes, and then it works on it as if it was it's kind of similar to if it was a function call. But and maybe I'm just being too pedantic here in terms of the terminology, but yes, this is all you need to do. And then the reasoner sees this and knows how to process this, and it knows that if it finds a pizza, which it did, that has a caloric content which is greater than 400, it classifies it as a high calorie pizza.
Does negative value also come under this, or?
Yes, yeah, you could use. I'm pretty sure you can use negative values as well.
Yeah.
I mean, it wouldn't really make sense in this context, but in general, yeah, I'm 99%. I haven't done it, but I'm virtually certain.
So the third bracket will come also then, right?
Sorry.
Third
Yeah,
bracket
so you would
will
say,
always.
well, here, let's just try it. Let's just try it. Let's say, so it's got a negative caloric content. Okay, so I mean that seemed to work. Here, let's try. So it's less than negative 400. And so we'll say negative 500. Yeah, so you can see, so so I said new pizza has a caloric content of negative 500, and I said strange pizza is a pizza that has a caloric content that's less than negative 400, and you can see that new pizza was classified as a strange pizza because it has a caloric content of negative 500.
Yes, sir. Thank you, sir.
Got it? Okay, cool.
Yes, yes.
Other questions? I know I went through the spiciness, the order thing kind of fast, but so if are there questions about that?
Are there any questions? Any other questions? Doubts? Okay.
Can we have Boolean as a value?
Yes, there is. So you go here, and let's say okay, and if I go to the range and built-in data types, there is somewhere, I don't know where it is, but I'm sure I know it's here someplace. There, wait, there, yeah. So here, XSD Boolean. Okay, so yeah, you can definitely have Boolean. And by the way, this also shows an example of how this is different than object-oriented programming. So you can see here, I've just defined a new data property, and I haven't even given it a domain, which I don't have to do. So so at this point, this has Boolean. I could assert this on any individual that I want, because if I don't give it a domain, it defaults to the domain of all things. So I can assert this on anything.
Any other questions?